Welcome to Database Performance Monitoring and Tuning and Databases as a Service. My name is Markus Strauss, Senior Product Manager at SolarWinds. And first of all, thank you very much for having us at the PaaS Virtual Summit in 2020. I'm really honored to be here. It's a pleasure to be here. And I'm looking forward to walk everyone through the topic at hand over the next 60 minutes. Before we go into the actual slide deck, I wanted to quickly shout out the PaaS resources. So I'll give everyone a second to read over this and give everyone a chance to have a quick look at the free resources that are available through paas.org. On the agenda, I will do a quick introduction. We will be touching on the challenges of database as a service monitoring. We'll have a quick look at the provider toolsets, benefits, and also drawbacks. So what toolsets come with your AWS provider, your Azure provider, or GCP? And we'll also have a look at overcoming monitoring challenges in that context. And we'll spend some time on individual items such as troubleshooting, how to tune query performance, and obviously the old faithful of monitoring infrastructure. And at the end, we'll have key takeaways. Obviously, at the end of the session, there is a Q&A session where I'll be happy to answer any questions that may have come up during the talk. So first off, the topic that nobody likes to talk about, and that's to talk about themselves. My name is Markus Strauss, like I said earlier on. I'm product manager at SolarWinds. You can reach me on LinkedIn if you want to. And I've been with SolarWinds just about 8 months at this point. I've spent considerable amount of time in other industries. Just before SolarWinds, I've worked and managed the database security products for McAfee. I've spent some time in the APM industry and in more industries than I care to admit at this point. And with that, I will leave it at that. Like I said, nobody likes talking about themselves too much. It's not the most interesting topic, but I'm really glad to be here, and I hope you all enjoy the session, and I hope there's going to be something for everyone in there as a takeaway at the end of this. So challenges of database as a service performance monitoring. It's an interesting topic, right? We have moved from predominantly monolithic database stacks to much more nimble stacks in terms of database deployment, in terms of database usage. And when we look at things like AWS RDS or things like Azure SQL, we have moved from, we have a big box sitting somewhere in a data center that is close to us to a service that is often very far away from where we are. And yet we still have the same, if not more, needs and requirements onto that service than we had before. So one of the biggest challenges that we, at least from my perspective and my experience, what we look at is the complexity, right? Complex architectures are something that is, it's often wanted. It's something that we need, especially in context of distributed architectures and things that we build to serve a customer need, or we build to provide better products, faster products, products with wider reach, thinking of, geographically split architectures, different regions, making use of that horsepower that a database as a service deployment allows us to do. But that is a challenge, right? At the end of the day, we no longer have the luxury of having the monolithic server rack sitting somewhere in a data center close by, where we essentially have full control over every aspect of that database deployment, where we can call up the sysadmin to walk down into the data center, where we can, remote log into the actual machine and observe how the machine on the infrastructure level is doing. We don't have that luxury anymore. And the more distributed our architectures become, the bigger those problems get in terms of understanding where to look when things start to slow down or when things don't go the way we expect them to do. We have very demanding workloads, right? With the increase in throughput, with the increase in flexibility on rolling out database deployments, and with the increase in complexity on the applications that we support, the production workload gets more and more demanding. And very often, the way I look at this and the way I often talk about this is, we have a huge array of different applications as a business that we support, often across various different regions, and from a cloud service provider perspective, often across various different geolocations. And all of these put demand on our backend databases. The third aspect on this is poor instrumentation, right? And I know from my own experience, in more cases than not, we don't build applications with instrumentation in mind, right? Instrumentation generally comes as an afterthought. Usually the driving factor of adding instrumentation is when something went south. We don't generally have the luxury of, when we build applications, to build in every level of instrumentation that we believe we could ever need. We don't have the time, we don't have the luxury to do that. And, albeit during designs and architecting, let's say a new application, there's certainly an emphasis on adding instrumentation to allow for better observability. But the problem is, when it comes down to it, to actually building it and developing it and deploying it, very often instrumentation is one of those items that becomes a stretch goal. And usually we are left with, we implement essentially, the bare minimums. But that obviously leads to the challenge of not necessarily being able to fully see into our deployment, not necessarily fully understand where potential bottlenecks are, where potential problems are, and where we have the ability to increase performance or make services run smoother, right? The other aspect of this is not so much on the actual technology, but what happens when things go south. In a world where, and unfortunately I'm old enough to remember, in the past, whenever I would go to a website and, let's say for argument's sake, would buy a pair of shoes, no, I'm not a huge shoe fan, but we'll stick with that. It was perfectly normal, acceptable to go onto a website and it loads for about 30 seconds or 40 seconds or sometimes longer, before it revealed all of the multicolored goodness of early 1990s websites. And that was perfectly okay, right? And we all knew that. We waited and we would go about whatever business we had on that website. But we all understand that those days are gone, right? The ability and the willingness of our end consumers, of our customers, to sit and wait has pretty much diminished. We're at a point where that dreaded X symbol, whether that is on the top right of the browser or whether that is in a mobile app or any other application, is very quick at hand. And again, I'm using myself as an example. If I today download an app for my phone and it doesn't load, or it errors out, or it takes me more than 2 tries to get anything working, that app is gone. And I will not go back unless it is absolutely business critical and it's something that I just cannot get around or get away from. But if that is not the case, then I can ensure you I will not use that app again. And that applies to the vast majority of our end customers, our end users. And the same goes in the business world for any sort of business application internally. If we build something internally where our internal customer relies on for whether that is business processes or sales processes or anything else, and if that piece of software does not perform because of bottlenecks in our backend, then the business is going to turn around very quickly and start pointing fingers, right? And we have a problem. The other aspect as a service is sometimes we don't really see everything because we have too much data points, right? It's very easy to get lost in all of the different data points when it comes to how we pay for our database as a service. There's a lot of different metrics that most of the cloud platform provider use in order to give us as the end consumer enough understanding to understand our monthly bill, right? But that very often doesn't go as far as to give us enough information to understand, are we actually at capacity? Are we over capacity? Are we under capacity? Well, the under capacity part gets fairly obvious fairly quickly because we generally run into a problem. But overall, it's very hard for us to understand whether the money that we spent into the services is actually utilized to the correct extent, right? So it's very hard for us to measure capacity and to understand whether we are essentially wasting money on those services. And the last part obviously is, and that's something I have kind of hinted in a point earlier on, we tend to have very siloed roles in a lot of the things that we do as companies, and that applies to pretty much every company, right? We have our DBAs, we've got our DevOps people, we've got developers, sysadmins, and everyone owns part of the overall puzzle. Where it becomes challenging is when something breaks down and we can't fully understand where the problem lies. The risk and chances of finger pointing become really, really big, right? It's very easy for one department to blame the other department and so on and so forth, because we don't have all of the data sets, all of the metrics available to clearly identify where the problem is. And that becomes a real big problem when we start dealing with the cloud platform providers, because obviously it's their infrastructure, it's their services. And if it's not performing to the extent that we expect, we're the ones that are hard pressed for evidence for that. We're the end consumer. We have to collect the evidence and provide the evidence back to the cloud platform provider, showcasing where performance dropped below an acceptable level. And without having that, we're essentially left in the dark. And I'm sure most of us here have dealt with situations like that, and pretty much generally without evidence, there is not much we can do, and there's not much the cloud platform provider will do. Understandably so. I think that's pretty much the same for every business, but it leaves us hanging in the sense that we are not able to essentially provide enough evidence to showcase where performance drop occurred. Whether that's on the actual infrastructure or not is irrelevant in that moment, right? We just don't have the metric evidence to essentially understand that, whether that's for internal use or external use. So a lot of you may think that this is a bashing session against a cloud platform provider. It's far from it, right? The point being, each one of these tool sets has benefits and drawbacks, right? Cloud platform providers tend to provide a lot of tools, and some of which we use and some of which we don't, and it's very situational. And some of these tools are absolutely fantastic, and the key benefits really are they're highly integrated, right? We don't have to worry about, especially in the cloud platform context, where as the consumer we no longer own the underlying infrastructure, and installing or using anything that is not provided by a cloud platform provider becomes, well, prohibitively complex or impossible, right? In some cases, it's just simply impossible to install an additional component onto something that's provided by AWS or Azure or Google, right? So the fact that the tool sets that the cloud platform providers give us, the fact that these are so highly integrated makes our life a lot easier because we don't have to worry about that anymore. And we know whatever runs there, by and large, runs smoothly in that particular infrastructure, right? And because it is built from very often the ground up to work within that particular environment, the performance footprint is generally very small. And again, especially in the database world, performance impact on anything that we do on the database or on the host machine or anywhere within that chain between the application and the database is something that we all, I'm sure, are very, very aware of, and we're all very careful about. Just to understand that, if we do install something or if we do hook something into the middle, that there is almost always a performance penalty. So having a tool set that's essentially designed from the ground up to work within that particular environment and that particular infrastructure generally provides us with a tool set that has very small performance footprint. And then there's the aspect of third party, right? Whenever we start thinking about accessing databases and installing something onto the host machine or connecting any sort of other service to our database, whether that's via JDBC connection or some other way, it's a third-party tool set, and it brings its own challenges. Whether that's internally in our business, where maybe our business is not very open to letting third-party tools live on our database host machines, or whether there is potentially data protection issues that we may face. So the fact that it generally doesn't require a third-party tool to be installed or anywhere near close to the database is, in a lot of cases, a really big benefit and allows us to get around the issues that we would often have with third-party providers, where we may or may not get to the point where we are allowed, capable from the business side of things to install or connect to the database directly. But unfortunately, like with so many other things, where there's benefits, there's also drawbacks. And as I said at the very beginning, part of our session really is to understand both sides, the benefits as well as the drawbacks, and to understand where a monitoring tool that lives outside of that particular ecosystem makes sense and where it may not, right? And one of the biggest drawbacks that come to mind when we start looking at cloud platform providers is the coverage, right? Understandably, when we start looking into the industry and start looking at the various different charts that exist, whether that's database rankings or anything in that respect, more often than not, we will see, and I think we all understand when we look into our own environments, we often use more than just one flavor, right? We may have SQL Server and plus, or we may run Oracle and plus, or we may run MySQL and something else, right? In a lot of cases, it's not just one. In many cases, it's even more than two, depending on what sort of environment, what sort of industry and business we're in. We may have various different types of databases, whether those are relational or NoSQL, document storage. There's a variety of different DBMS. The problem that we'll run into is that in a lot of cases, when we start looking at cloud platform providers, our spread might look something like this, right? We might have some SQL Server, some SAP HANA, some MySQL, bit of Postgres, or any of the other ones, right? This is generally a very typical setup. And in a lot of cases, the problem then becomes that not all may or may be covered by the cloud platform provider that we're working with, right? We may use SQL Server. For example, we may use Azure SQL, right? We may use a form of MySQL as a service, right? But we also may have a bunch of SAP HANA instances that just run on normal Azure VMs. That's all well and good if we can get metrics from the cloud platform provider for the Azure SQL and maybe MySQL. But what are we going to do with the SAP HANA, or what are we going to do with Postgres, right? So we end up essentially looking at a bunch of different tool sets. And the other point is, even from a monitoring perspective, not everything is created equal, right? We may look at different levels of integration. We may look at different levels of coverage. We may look at different levels of granularity. So at the end, we're not necessarily left with an equal dashboard, right? If I'm using the term dashboard as our single landing page, and if I'm responsible for an environment broadly, not just one subset of an environment, but if I'm responsible for an environment, I want to make sure that I have some way of getting all of the environmental data, whether that's SQL Server, whether that's MySQL, whether that's MongoDB or Redis or any of the other ones. I want to make sure I get all of these to the same level of monitoring capabilities. I want to make sure I get all of these to the same level of metrics, the same level of granularity, so that when I look at the metrics across my environment, all of those data points make sense. If I have to recalculate how my mind operates when I look at graphs, depending on the database type, that gets old very quick. And it's also not very conducive to things like troubleshooting or things like understanding how some items are correlated against others. If we're not looking at the same scale, then there's virtually no way of correlating data. So this is a unfortunately typical example of what, on average, something like this would look like. We had MySQL and SQL Server perfectly monitored, albeit maybe with slightly different metrics, and maybe not the same scaling and other things. But I could look over that and I could look past that. But where the problem starts becoming very apparent is we add Redis and SAP HANA and Mongo into the mix. And obviously, mind you, these are somewhat arbitrarily chosen as an example for what the average deployment might look like, right? But what I end up with is by no means an arbitrary problem. It's a very real problem because I now have an unequal feature set. The database support isn't equal across the board, and the granularity is not equal. So going back to the point I made just a minute ago, we now have, albeit tool sets for all of the different database platforms, but we're not monitoring them equally, and we're not looking at the same type of data sets. So in essence, whichever poor person is ending up having to look at these charts cannot cross-correlate anything. I may see something in the environment that I believe it could be a noisy neighbor scenario. I could have a physical box that runs several different services, and I have a noisy neighbor problem, but I won't be able to cross-correlate that because it's not supported to the same level. I may not have the same granularity of data, and I might get certain pieces of information in one tool set and certain pieces of information in another tool set, and stitching all of this together is, depending on the size of your deployment, is virtually impossible. I mean, I can do that over 2 or 3 different instances, but once it gets past that, and you get into somewhat more real-world scenarios where you have 20 plus, 50, 100, 500, a couple of thousand instances running, that's a nightmare. You won't be able to to correlate anything. You're left with essentially firefighting, because you can only narrowly focus on the issue at hand and use the stats and metrics collected for that particular environment to essentially work through that particular environment's problem. But there is no benefit of understanding how that has an impact on any other services that may or may not be connected to that. One other challenge that we have with provider toolsets is, and that's not necessarily just limited to the provider toolsets, that's a general problem we see across a lot of the monitoring space, is the monitoring approach. The monitoring happens essentially very traditionally from the bottom up. We start with the infrastructure health. That's where most of our effort sits when we monitor, meaning we get the majority of our metrics that we collect are infrastructure-based metrics. That's your CPU utilization, your memory utilization, any of these. That's something we're used to and familiar with, and in a lot of monitoring approaches, that's where the lion's share of the data comes from. The next level down, really, we're looking at the database service health, right? So, is the service running properly? Do we have potentially, if we're going into the I suppose the recommendation area, do we have services running that are not necessarily required anymore? If we're looking at SQL Server, any of the old XP services for connecting to the operating system, for example, is one of those very good examples. Wouldn't necessarily recommend anyone having that running unless it's absolutely required. But again, that's more on the actual service itself, not necessarily on how does my database perform. And I think one of the biggest challenges is to understand what I mean by how does the database perform. Do I mean how does the box perform? Do I mean how does the service perform? Or do I mean how does my query workload perform, right? And the traditional monitoring approach, which is across, like I said, a lot of different monitoring products, whether that's provider toolset built-in products that are not really products per se, or whether that's third-party products, the traditional monitoring approach really is from the infrastructure level, getting gradually less into the query workload. Whereas, interestingly enough, the problem description may be slightly different, and I'll get into that in a little bit. So now that we've talked a little bit about the challenges and the benefits and drawbacks of the provider built-in toolsets that we can make use of, let's start having a conversation about how we can overcome those monitoring challenges and what we need to do to get to a level where we have confidence in the metrics that we collect. We have confidence in the knowledge of the database environment, irrespective of the location, whether that's on-prem or in the cloud. In this particular case, especially because it's database as a service, a cloud-based service where we don't have access anymore to the infrastructure. Very different scenario to what we're used to in a lot of cases. So overcoming the challenges, I would want us to go back to the beginning of the conversation when we started looking at the challenges. And I kind of boiled them down into essentially two different challenges. One is the complex architecture, and the second one being the poor observability, meaning lack of instrumentation and things like that. And the interesting bit, complex architecture aren't a challenge. They're not a problem. It's something that we have created, and it's something that we have created for a reason. And that reason is to provide better services, to provide better products, more distributed services, faster access times for our customers across the globe, no matter where you are physically located. All of these things come on the back of complex and distributed architectures. We wouldn't be where we are today without these. So a complex architecture by itself is not a problem. The problem comes from having tools that do not necessarily interact with each other or provide the same kind of, I'm going to use a very, very bad marketing term, single pane of glass. Um, and I know, but it is rather fitting, right? In the sense that we don't have something that is a source of truth where we can look at and we understand that every metrics is calculated the same way. Every metrics looks at the same equivalent type of metrics within the database. Obviously, not every database is the same, and not every platform is the same. But at least we have equivalents to what we look at. We understand that the granularity is all the same across the board, so that if I look at a snippet in time, I know that there is data collected for, let's say, for argument's sake, in a second level of granularity across every platform that I'm monitoring, and not having the problem of one may be displaying in second increments, the next one might be only displaying in minute increments, and so on and so forth, making it impossible for me to understand time-related events, or correlating based on time, right? The poor observability goes back to what I said earlier on, right? In essence, one of the biggest items we see there is that the fact that we're not really looking at the problem from the right angle anymore. And given 10, 15 years back, looking at a database problem from an infrastructure perspective was certainly warranted, and certainly the best way to go about it, because we could throw money at the problem and scale, and we could throw more memory, more CPU, more horsepower at the box, and we knew we'd get some performance benefit out of it. Now that has been taken away from us and put into a much more automated way, thinking of elastic scaling and things that we can do within the database as a service world that we just can't do to that extent traditionally, we kind of have to start looking at the problem from a different direction. Because now, just in terms of understanding what a problem is, throwing resources at the problem isn't going to necessarily fix it anymore. Because, well, for one, the service, if designed that way, is going to scale automatically, right? So that's out of our hands. If we scale ourselves, just throwing a bunch more services on it and creating a bunch more instances, it isn't going to necessarily solve any problems. It is definitely going to increase our monthly bill, and there is no measurable benefit for that, right? And again, we have tool sets that we can use to understand our cost, but we don't necessarily have tool sets to understand how impactful that expansion just was. Did we save anything in terms of performance? Did the overall performance get much better? So when we start looking at the complex architecture, the solution is quite simple, right? And I kind of talked around it for the last couple of slides, but essentially we got to be able to have a holistic view of the environment, starting from the database perspective. The infrastructure aspect certainly still very important. If I go back to the problem set earlier on, where we talked about the fact that if there is a problem, a degradation in service, we are the ones who need to prove that the degradation happened back to the cloud platform provider. So infrastructure-based measurements and metrics are still important, and I don't see anytime soon where this is no longer valid. But we do need to capture everything else, and we need to capture it from the perspective of the database workload, not from the perspective of the infrastructure workload. And we no longer own that. That's I wouldn't say no longer our problem, because it certainly is, especially if it goes wrong. But it's no longer something that we have an awful lot of control, if any, over. Where we do have control over is actually what goes in and out of the database and what attaches to it. So we need to change the way we look at this and start from the database perspective, and still include, obviously, our infrastructure. And we've got to be able to correlate all of the different metrics that we collect, whether that is infrastructure based, whether that is query based, and we got to be able to bring that all together and correlate against each other. Because again, going back to the point that was made earlier on, if we have tool sets that do not use the same metrics, that do not use the same time formats, that do not use the same granularity, any of these tasks are virtually impossible. Yet we are at a point where if you are looking at monitoring database as a service, you no longer care all that much about the traditional infrastructure monitoring, because let's face it, you have no control over this. We don't have real impact and influence over that anymore. We can't just walk down over to AWS and say, hey, throw another server into the rack there for me, will you? It doesn't work like that anymore, right? So we need to change our approach and start correlating those things based on what is important, and that is looking from the database. So with that in mind, let's have a look at the problem distribution when we start comparing this to the monitoring approach from earlier on. In the vast majority of cases, when something does not work the way it's supposed to work, or something breaks down, a service stops to respond, an instance just goes dark, in the vast majority of the cases, the problem can be traced back to not the infrastructure health, not the database service health, but the query workload itself. If my query workload, i.e. the SQL I'm sending to the actual instance, is not well designed, it can cause all sorts of problems. And I'm sure we all know that. I'm pretty sure we've all come across queries like that, where someone just made a quick change somewhere and it screwed up the server for days after that, because we needed to figure out where that change is, what that change is, where it came from, and go over to the person who introduced it and ask nicely to change that, right? So we need to start looking at it from the query workload down, and we need to start analyzing all of the metrics that we're collecting from the query workload downward. Unlike what we've done in the past, where all of the monitoring essentially started with the bare bones machine and went into the query workload from there. But we'll see now with the change in how we deploy databases, how we use databases, the simple fact that it is no longer a machine that we have control over. It's not even a VM anymore that we have control over. It's a service that we have access to, and we can certainly make changes to. And we can certainly increase some of the infrastructure parameters, but ultimately we don't have control over it. At the end of the day, the most important aspect of understanding any sort of database performance is understanding the query workload and its impact on the environment. There's certainly aspects of the infrastructure health can have an impact on how my environment performs. Absolutely. If I have 256 gigs of RAM and half of it goes dark, that certainly will have an impact on how the overall service will perform. There's no question about that. But again, those are relatively rare, and I'm using air quotes, relatively rare in comparison in the as a service world, where we don't own the environment anymore, and the environment is built around a service always on architecture. So let's start diving into some more individual aspects of how can we overcome the monitoring challenges. And I'm going to start off with the one item that I think we are all and every one of us most familiar with, albeit not necessarily those are good thoughts, but troubleshooting. I think we can all agree that that is probably the vast majority of interactions we have with any sort of monitoring. Is when things go south, we got to be able to fix it, right? And when things go south, we got to be able to understand where the problem is, locate it quickly, and solve it, right? So mean time to response is, MTTR, that term gets used very often. And it applies to anything in the database as well, right? We've all been there. Someone calls us at 1 o'clock at night, tells us that the service is dead, nothing works anymore, and we scramble and log into whatever toolset we have available, and we start frantically looking for the reason. Obviously, after we've restarted the box or whatever it is, if we can, and figure out how did that happen, why did it happen, right? So from a troubleshooting perspective, the ability to really correlate the query behavior against anything else and everything else in the environment, right? So if we start seeing we have one particular query that, for example, I have one particular query that generally gets used, gets called, let's say, 2,000 times a day, and it's our sign up. It's part of our sign up routine, right? So when a new customer signs up online, that query gets called as part of that process, and it generally happens about 2,000 times a day. That's not bad. That's good going. That's 2,000 new signups a day, right? But suddenly we're seeing that that particular query was called 25,000 times within the last hour. Well, we kind of know something isn't quite right. We either have done something really, really well, and our signups suddenly gone up by an order of magnitude or a few, or something has changed in the environment. So we got to be able to take that and correlate that query data just alone based on the amount of times that query was called and the ability to see that over a period of time and understand that this is unusual. We got to be able to do that. So we got to be able to isolate anything that we deem unusual. And obviously there is an aspect of personal knowledge that has to be there. If I look at a query and I know it's the sign up query and it normally gets called 2,000 times a day, and I now see it being called 25,000 times, then I know that is unusual because I know what it normally looks like. But even if I don't know that, I got to be able to expand my time, the window through which I'm looking at the data, and understand whether the 25,000 is normal behavior or it's unusual behavior, right? I got to be able to look at individual queries and understand, well, if I have a query that spends a huge amount of wall clock time, is it something that is in how we distribute it query? Is it we've got two services where that query essentially gets distributed amongst? One of them runs on a slightly different version, or something is different, and one service takes up about 90% of the query workload time, just because it's a different type of service, or we've got something configured differently or wrong, God forbid. We also got to be able to look at things like execution plans and understand, are we doing full table scans? Are we using indexes, or did we forget about it again, or something along those lines? So we got to be able to use all of those things fairly quickly in order to establish whether a slow or timeout performance of a service that we're responsible for is based on, well, the cloud platform provider itself is having service degradations. We can correlate all of that against the metrics that we collect for the infrastructure. Whether it's something that was newly introduced into our environment, any sort of code changes, anything that we've pushed out. Was it something that we didn't expect because we had a huge marketing success? That's fair, but still it causes problems in our environment, so we need to account for that and build for that in the future. But nevertheless, we got to be able to correlate all of this fairly quickly in order to get to a root cause and fix the problem and do root cause analysis and create postmortems and things like that. Because at the end of the day, we're normally asked for that sort of write-up, and understandably so, right? Because we've just lost the service for a number of hours, and potentially there's a bunch of customers who's not very happy about that. We may even have lost revenue because of that. So we got to be able to pretty quickly get all of this together and then, create the post-mortem, do the root cause analysis, and make sure we put steps in place to ensure that doesn't happen. That's incredibly difficult to do when we have 3, 4, 5, 6 different tool sets to use, right? And I think we all can agree on that. The next aspect, after really kind of having been called at 1 o'clock at night, the next aspect of this really is coming down to the tuning aspect, right? After we've put out the fire, we usually have a bit of spare time. And in our spare time, what we'd like to do is, well, how can we tune the database performance? Again, somewhat easier in traditional on-prem type setups than it is in the database as a service world, because again, we don't really have the same level of access to the infrastructure, right? But that doesn't mean tuning stops, right? Tuning still exists, and we still need to make sure that, anything and everything that gets put into the environment, anything and everything that we essentially push out, whether that is new code deployments, whether that is things like changing services, we're adding new services into the mix. If we're still running none as a service infrastructure, right? Because quite often, again, we run things in parallel. We may have a number of instances that run as a service, and we may have a number of instances that are running traditionally, albeit maybe in the cloud, on an EC2 instance or on an Azure VM. We are still got to be able to make sure that all the critical updates and everything is configured correctly. Those things may sound trivial and kind of obvious, but I'm pretty sure we all can imagine that when we build out deployment routines for new databases and services, we generally try to bake the best possible configuration into whatever service we use to roll out new databases. But if you're living in a world where the create and destroy cycles get shorter and shorter, we keep spinning up stuff and destroying it and spinning up something new again, it's incredibly easy to lose track of which version is deployed on which instance and which configuration change was made where. And yeah, of course, when we deploy ourselves, we can use things like Chef and other ways to deploy and make sure that we've got everything set up in such a way that it's always the same image and it's always the same configuration. But again, that's kind of gone in the as a service world, right? And even there, you may have different database versions that you can use, right? I'm looking at RDS, for example, right? If I were to use RDS Postgres, I can use several different versions. So not every version will have the same type of configurational changes that we would like to make, and we gotta remember these. So we have to have a way to see all of this, especially in larger environments where it's, like I said, incredibly difficult to just keep an eye on that manually, or even with built-in deployment routines. It becomes overwhelming very quickly. But the tuning goes much further than that, because obviously we need to understand that, for example, how does our query perform, and maybe what we could do to make that performance better. Again, it goes back to the point I made earlier on, where like in a lot of cases when we deploy applications or deploy updates to applications, and I'm sure there's developers among us here as well, one of the benefits of, depending on what flavor we use, there's usually libraries available that auto-generate our queries for us, so that we don't have to type queries and create them manually every time we need to write code that accesses data. And while this is fantastic for the developer, and while this is absolutely fantastic for creating repeatable source code that uses the same structure and can be relatively easily reviewed and deployed, it's not necessarily the best way of creating a high-performing query, right? Those libraries are not necessarily the best way to create high-performing queries. Now, I'm not going as far as saying that those libraries forget to add indexing or use indexing, let's put it that way. But there is still a lot of room for queries that enter our environment that, for example, don't make use of indexing, and we have it available, right? Or we deploy a new table and someone didn't do indexes properly, right? Realistically, we want to know about this before it becomes a problem, right? We want to know this here before we're here, right? We don't want to find out that we have a whole customer table that gets accessed a couple of thousand times a minute, and we forgot to actually add indexes. We don't want to find that out here. Preferably, we want to find that out here, right? We want to be able to have a tuning process. Part of our general daily, well, maybe not daily, but our general routine is the tuning aspect of the database workload that we're managing. And we obviously want to be able to make those changes, or at least see that those changes are required before they turn into a potential problem, right? And we have to have a tool, again, going back to that point, we have to have a tool that treats all of these the same and allows us to see all of these recommendations, see all of these flags around whether we have poor performing query syntax, where we have where clauses that aren't limited correctly, and where we have explain plans where we can clearly see we do full table scans, and maybe that's required, maybe that's necessary. I'd argue it isn't, but at least in most cases. But it all goes back to the point that we have to have a way to see these things, and to see these things before they become a problem. In the vast majority of the cases, being able to see all of these will essentially cut down and cut back the troubleshooting that we need to do, because we're ahead of the curve, we're ahead of the problem, and we can make sure that everything runs as smooth as possible. And it is incredibly difficult to do that with a myriad of different tools, right? Because not only do I have to learn different UIs, the lingo, the different setup, the different way how to correlate things and all of those things, but I may also not look at all of the data sets equal, right? So we have to have a way to see all of this in one place. We're slowly starting to come to the end of this. And at the very end, a little bit in the fashion of the problem statement or the problem distribution earlier on, we come to the infrastructure part, because despite all of what I've said, there is obviously still an element on the infrastructure that we should not and cannot deny. Even though this may be database as a service, it still runs on an infrastructure. And albeit it may not be our infrastructure and we may not have ultimate responsibility for the infrastructure, we have a much greater responsibility, and that's with responsibility against the service that runs on that infrastructure, which makes our job already much more difficult, because we've now been essentially taken away part of our tool set, i.e. the infrastructure. We're still responsible for everything, but we are not really responsible anymore for the infrastructure, right? So I kind of touched on this earlier on in several different points, right? But the ability to essentially correlate all of what we just talked about back the actual infrastructure. So whether that is, your golden signals, right, your throughput and latency and concurrency, referencing that against particular query performance, understanding what your disk IO looks like. Maybe you do need to swap into an instance or a service with a faster SSD, right? Maybe you do, but you got to understand and know where to look for. But also, very importantly, understand the resources and capacity, right? I mean, going back to the very, very beginning of this conversation, we have to understand that, albeit we can, as easy as never before, start rolling out more of something, it is difficult still to understand whether that more of something is really giving us bang for the buck. Because we don't necessarily see whether the additional 3 instances that we just requested and spun up have any noticeable difference other than what we perceive to be a difference, right? And all of these things are attached to finances, money that we spend, right? So the ability, especially during the initial migration phase, to understand, to monitor and compare what we used to have, or even, let's not even go to migration from on-prem, but migration from, let's say, a more traditional instance on a VM, whether that's an EC2 or an Azure VM or a Google VM, to a database as a service, there's still going to be performance differences, quite naturally, right? We have to have the ability to monitor this pre and post migration in order to really understand that the money that we spend upgrading the service really does give us the impact that we needed, or whether we need to make changes on how we deploy those services, how we utilize those services, right? And we still got to be able to do all of the things that we used to do and understand how the environment fares, even though we don't have any direct influence over it anymore. And we still got to be able to look at the performance of the environment pre and post any event, whether that's Black Friday, whether that's what we just rolled out, new piece of software, new code. We still got to be able to compare pre and post that particular event in order to understand how did our overall environment fare against that particular event, and where do we potentially need to make changes? Do we need to swap servers into something with, like I said, faster SSD, more throughput, different type of sharding, any of those, right? So with that, we're kind of getting to the very last part, which is the key takeaways. And the key takeaways have to be that ideally we would want to have a single tool set with broad database coverage, where we can see detailed query behavior across all servers and services, and where we can very easily and quickly identify outliers and diagnose issues. We got to be able to have health and configuration issues that we can check very quickly. We've got to be able to see that at a glance. I don't want to be spending 5 minutes, 10 minutes wading through different tool sets in order to figure out whether this particular tool set actually tells me whether my configurations on a particular set of instances is up to snuff or not. I got to be able to see that fairly quickly and very easily. And I got to have recommendations on how I can optimize that, because I'm under no illusion, and I'm pretty sure we're all the same here. I'm no expert in every database. I'm no expert in every DBMS. I'm no expert in every possible deployment scenario. So I'd like to be able to have a set of recommendations that I can look at. Some of them may apply, some of them may not, but at least it's a baseline I can work with and understand that when we create new services or we deploy new services, it runs against that particular baseline, and the chances of something slipping through are very, very little. And all of this needs to be in one platform, one tool set, not 5 different tool sets with 3 different metrics and 2 different granularities. And with that, I'd like to thank you very much for spending the last hour with me. Your feedback is always very, very welcome. And like I said, I'm online to answer any questions that you may have. And again, thank you very much for taking the time. It was a pleasure talking to you. Thank you.